This is a video to help you review solving two-step equations. So right now we're going to stick to only variables on one side of the equation. So let's look at one to start with. So let's do 6x minus 10 is equal to 32. So we can look at this a couple different ways. So we can think of it as what's being done to the variable. Well, first, here's your variable. You would multiply it by 6 and then subtract 10, and you got 32. So you took some number, you multiplied it by 6, and then subtracted 10. So to get back to the original number, you have to do backwards and opposite. So the last thing you did was subtract 10, so undo that by adding 10, and then before that you had multiplied by 6, so now you're going to divide by 6. So backwards and opposite operations. Another way we can look at it is you're trying to figure out what x is. So when we're looking at one-step equations, we're just used to like not having this there at all. And then being able to undo this multiplication by dividing. Well, we can't do that until it really is by itself. So I don't know if that's there we go. So we want to have the term with the variable by itself. So 6x is the term with a variable. So we need to get everything else to go to the other side. So we want to get rid of this and make it 0. So how do we make subtracting 10 0 or a negative 10 0? Well, we're going to do the opposite. So we're going to add 10. And remember, what you do to one side, you must do to the other. So we're going to add 10 to this side as well. I'm going to use my line to help keep track of my equal sign. So this negative 10 plus 10, we combine them because they're like terms. We can't add 10 to 6x because this is 6x's. This is 10 ones. So negative 10 plus 10, we can simplify that, and that becomes 0. So that zeroes out, and we're left with just 6x on the left side of the equation. On the right side of the equation, those are like terms, 32 and 10, so we can add them together to get 42. Now we're back to something that looks more familiar. So I have a term with a variable on one side, the term without a variable on the other side, or a constant term is what we call it when it doesn't have any variables. So now we can separate the variable from its coefficient by dividing. So since this is 6 times x, we want to divide each side by 6. Then 6x divided by 6 is just x, or you can write 1x, is equal to 42 divided by 6 is 7. So our final answer should be 7. So checking your answers in problems like these becomes more helpful because there's multiple steps. So we want to plug in 7, which we're saying is the answer, our solution, in for x, because we're saying that's what x has to equal in order for this statement to be true. So 6, and then I'm going to put my answer in parentheses since it's being multiplied by the coefficient. So 6 times 7 minus 10, is that really equal to 32? So remember, this side we don't have to do anything to, it just stays 32. But this side we've got some things to do. So we're going to evaluate this side or find its numerical value. So just figure out what it simplifies to. So order of operations, we have to multiply first. So 6 times 7 gives us 42. Minus 10, is that really equal to 32? And then we can do, what is 42 minus 10? It's 32, and 32 is equal to 32, so both sides are equal, therefore our answer is correct. So the answer to this equation is x is equal to 7. Let's do another one. So I'm going to use the variable m this time. So 5m plus 28 is equal to 13. So again, we want to, before we can separate the variable from its coefficient, we need to get the term with the variable, so this whole thing by itself. So right now, on the left side, we have the term 5m and 28. We just want 5m. So we want to get rid of a positive 28. So to do that, we're going to subtract 28. And what you do to one side, you have to do to the other. Again, we can't combine 5m and 28 initially. We could not make that any simpler because this was m's and this is 1's. Same thing here. Since we're subtracting 28 ones, we have to subtract that from the other ones, not from 5m. So 28 minus 28 zeroes out, and that's what we wanted to happen. That's what we expected. And we're just left with 5m then on the left side. Is equal to, now be careful, this is 13 minus 28, so we've got a number minus another number. Since 13 is less than what we're taking away, this result should be a negative number. So make sure that you are being careful when you're doing this, and you might just want to grab a calculator to check to make sure that you are subtracting correctly. So that ends up being negative 15. Now, again, we're back to something more familiar, a term with a variable and a term without. And so to separate the variable from its coefficient, that's multiplication, 5 times m, so we want to divide each side by 5 to get rid of the 5 and make it just a 1m. Again, because 5m divided by 5 is just m, or you can look at it as that fraction reducing. 5 divided by 5 is 1, giving us 1m or just m. And then negative 15 divided by 5, again, you might want to pull out a calculator to make sure that you're doing dividing with multiplying, or dividing and multiplying with negatives and positives correctly. So negative 15 divided by a positive 5 is a negative 3. So box that up. So that should be our final answer. Again, it's really important to check, especially when we've got negative answers, because we want to make sure we didn't mess anything up. So we're rewriting the original equation, but instead of m, we're writing our solution. So I'm just going to write it without it right now. So right now this is our unknown, our m, but we solved for it and said it had to be negative 3. So we're going to put a negative 3 there and make sure that this equation really is true, that this is really equal to 13. So that's why we put our question mark. So 5 times negative 3, again, you might want to use a calculator to help you out. But that's negative 15 plus 28. Is that really equal to 13? So you don't stop here. You need to actually calculate this. And on an assessment, like, don't make me do the work. You should be able to do the work. That negative 15 plus 28, yeah, that really is 13. So 13 is equal to 13. And we put a check mark to show that our answer is correct. And we know we're correct. Okay, let's do some more. All right, so this one, we've got 14 plus 3x is equal to 7. So notice that this one is in a little different order than we've seen before. The last two problems, and a lot of times you'll see that the variable is written here. The term with the variable is written first. But it doesn't matter because this equation is the same thing as this equation. So it doesn't matter what order it's in. And that is actually the same as this equation. We can also switch which side of the equal sign everything is, or not everything, but we can say, oh, I'll just put the equal 7 over here. So we can write these lots of different ways. So our purpose, though, in the way of solving doesn't change. We want to get the term with the variable, so the 3x by itself. Right now, 14 is being added to it. So we've got 14, a positive 14, because since there's no negative sign in front of it, it's a positive 14 plus 3x is equal to 7. So I'm going to get rid of that 14 by subtracting it from both sides. So again, keeping track of my equal sign there. So 14 minus 14 will zero out and give us 0. And then we're just left with a positive 3x. And we don't have to put that plus sign. The only thing we'd have to worry about is if it was a subtraction sign, then this would be a negative 3x. Over here, 7 minus 14 is negative 7. And again, back to something we're familiar with. Now we can get the variable all by itself by dividing by 3. Because this is 3 times x, to undo multiplying by 3, we're going to divide by 3. So 3x divided by 3 is just x, or 1x. Now look here. This is not a nice number. Do not plug it in on a calculator because you're going to get a repeating decimal. That's the correct answer, but whenever you have a repeating decimal, leave your answer as a fraction. What fraction is it? It's just this. Whatever you put into the calculator, that's the fraction that the decimal is equal to. So we just write it, -7/3. That's it. That's your final answer. A lot of students ask me, well, you don't want me to actually do it? Well, we are doing it. We're just not converting it to a decimal. So you're used to, when somebody asks you to do this, to type it in on the calculator and get the decimal approximation. But I don't care about that. I want the exact answer, which is -7/3. So our answer this time is a fraction, but it's okay. We can do it. We can check with a fraction. So check our answer. 14 plus 3 times our answer, which we're saying is -7/3. So we're saying x has to equal -7/3. And since my answer is a fraction, I'm going to go ahead and write 3 as 3/1 to help me multiply easier. And we want to check, is that really equal to 7? So over here, I still have my 14. There's nothing to do with that. So 14 plus, then here again, we've got a fraction multiplied by a fraction. You can multiply across or do cross reducing. So if I multiply across, you do, if I just multiply normally, 3 times -7, multiply the numerators, you get -21, over the denominator times the denominator. 1 times 3 is 3. And then we can actually reduce that. -21/3 is the same thing as -21 divided by 3. So that's just -7. Is that really equal to 7? Now the way I like to do this is to just cross reduce. So I see I have a 3 in the numerator, 3 in the denominator. Those cancel to become 1. And then I've got a denominator of 1, and then 1 times -7 is -7. So my answer is an integer. It's -7. So you get the same thing no matter which way you choose to do it. Now we just have to finish. So it's 14 plus a -7. Again, use a calculator if you think you're going to mess it up or just to check yourself. But that is 7. So 7 equals 7, and that is our correct answer. So even if we get fractions, it's okay. We can check them and make sure that they are correct. All right, let's do another one. Let's do 23 is equal to -4x plus 16. So again, this one's a little different just because our variable's on the right side now, our term with the variable. So our goal is still the same. We want to get the term with the variable by itself. So we're just going to leave it alone. Leave it alone. And we want to get this by itself. Right now, 16 is being added to it. So we're going to get rid of a positive 16 by subtracting 16, and we're going to do that to both sides. Keeping track of my equal sign there. The 16 minus 16, that zeroes out. And then we're left with just -4x on the right side. And then 23 minus 16 is 7. All right, and then we are going to do our final step here. So we have a -4 times x is equal to 7. Since this is multiplication, the opposite operation is to divide. Even though we see a negative here, that doesn't mean we're going to add. We undo the operation. So since it's -4 times x, we're going to divide by this number, which is a -4. So we divide each side by -4, because then a -4 divided by -4 becomes 1. Okay, the negatives cancel out, and the 4 divided by 4 is 1. And that gives us x, or 1x is equal to, and again, let's just leave it as a fraction, -7/4. Now this one, technically, you could write it as an improper fraction, or, I'm sorry, it is an improper fraction. You can write it as a mixed number or a decimal, since the decimal terminates. So I don't care how you write it. You can write it like that. You can write it as -1 3/4, or you can write it as -1.75. The only reason it's okay for the decimal is because it terminates. It's not a repeating decimal, so that's okay. I don't care which version you use. Now, when you go back to check, I will say the version that you shouldn't use is this one when you go back and check, because if you're going to use a fraction, if you write it as -1 3/4, you're going to end up converting it to -7/4 in order to multiply anyway. So when you check, either do the improper fraction or the decimal. I'm going to go ahead and stick with the improper fraction. So to check our answer, we're going to say, is 23 really equal to negative 4 times our answer of negative 7/4 plus 16? So negative 7/4, all I did was plug that in for our variable x, because we're saying that's what x has to equal in order for 23 to be equal to negative 4 times that number x plus 16. So I'm going to write negative 4 as negative 4 over 1, again, to help me multiply fractions easier. Okay, so we've got 23 is equal to, since I don't have anything to do on that side, again, we can multiply across. Negative 4 times a negative 7 is a positive 28 over, I don't use the negative again, I already did. There's not two negatives. So it's just a positive 1, same thing here. I already used the negative for the numerator. So positive 1 times a positive 4 is positive 4. And then 28 divided by 4 is just 7. So that gives us 7 plus 16. Now, I like to do it the cross reducing. So there's a 4 in the numerator and a 4 in the denominator. So I can divide them each by 4 and reduce to 1 and 1. And then you've got to be careful just not to forget those negatives. So those negatives will cancel out, because a negative times a negative is a positive. Then I can see my denominator is 1, so it's an integer. And then 1 times 7 is 7. So I get 23 is equal to, and then so I already got 7, right? So then 7 plus 16 is also 23. So we know our answer is correct. Okay, we'll do one more. So let's do 18 minus 13x is equal to 122. So we want to get the term with the variable by itself. Be careful here, because this minus sign is applying to the 13x. So you can rewrite this as 18 plus a negative 13x equal to 22 to help you out if you want. But the 18 is positive. The sign in front of the number determines whether the number is positive or negative. So this is a positive 18 minus 13x or plus a negative 13x. So the minus applies to the 13x. So in order to get this term by itself, we want to get rid of a positive 18. So we're going to subtract 18 from both sides. So 18 minus 18 zeroes out. And again, this subtraction sign, since we're subtracting 13x and there's no longer anything in front, it's like we're doing 0 minus 13x, which is a negative 13x. So you've got to keep that negative sign with the 13, with the 13x. So negative 13x is equal to 22 minus 18 is 104. Again, we're back to something that's familiar, and it's multiplication. Negative 13 times x. Negative 13 is the coefficient of x. So to get rid of multiplying, we divide. Since that number we're multiplying by is negative, we want to divide by a negative. So you divide by negative 13. Just because you see this minus sign does not mean we add 13 to get rid of it, because that won't work. Adding does not undo multiplication. Dividing does. So divide negative 13x divided by negative 13 is just plain x is equal to 104 divided by negative 13. Use a calculator, and you'll get negative 8. All right, now we want to go back and check our answer. So we're rewriting the equation exactly, except where we see x, we're going to replace it with the solution, or what we say is the solution. And we're going to make sure that this is a true statement. So is 18 minus 13 times negative 8 really equal to 122? Be careful with the order of operations here. You can't do this first. You have to do multiplication. It's 18 minus 13 times 8, not 18 minus 13, then the result times negative 8. This comes first, multiplication. So be careful here. I like to treat the 13 as a negative, so looking at it as plus a negative. So we're actually doing negative 13 times negative 8. So our answer will be a positive number. So it's going to be 18 plus whatever our answer is. So negative 13 times negative 8 is 104. Is that really equal to 122? And then we can add 18 to 104 we do get 122. And then we can put a check to show that our answer is correct. So that's it for solving two-step equations. If you have questions, let me know. Otherwise, do some of the practice problems that I have provided for you. Thanks for watching.